Apache Ambari is a software project for provisioning, monitoring, and managing Apache Hadoop clusters. Two important modules of Apache Ambari are Ambari Server and Ambari Web. In the current system, Ambari Web uses polling based mechanism to pull the data from Ambari Server. The goal of this project was to replace this mechanism via WebSocket. WebSocket provides two-way communication between the client and server. So the benefit of using WebSocket in this project would be that WebSocket will allow Ambari server to perform robustly in a large cluster setup with multiple browser sessions and when continuous heavy requests are being made. As a part of OSS project, we implemented a simple WebSocket client server isolated from Apache Ambari and successfully deployed it on Jetty 9. Now the next step was to ingest this WebSocket implementation into Apache Ambari. So while going through the code base of Apache Ambari, we found out that Ambari server runs on Jetty 8. Now the problem with Jetty 8 is that Jetty 8 only provides WebSocket client and server interfaces and not the implementations. So we had two options at that time: either implement those interfaces for WebSocket or upgrade Ambari server from Jetty 8 to Jetty 9. So we discussed with the Ambari team member Jamin and came up with the final decision that upgrading to Jetty 9 would be a good solution with respect to the project, because at some point of time project team would have decided to upgrade its Jetty server. So a few things about Jetty 9. So Jetty 9 is a huge upgrade from Jetty 8. So important features of Jetty 9 are that it has an inherent support for WebSocket protocol. So the implementations of client and server for WebSocket called JSR 356 was included in Jetty 9. Also, Jetty 9 implements the SPDY protocol, which is a new upgrade in the network transport layer, and it greatly improves the page load times without making any changes to your web application. So the next step was to upgrade Jetty from Jetty 8 to Jetty 9. Now while upgrading to Jetty 9, we faced a lot of challenges. One of the biggest challenge was that there is no particular Jetty migration guide available on the internet which shows what changes they have made from the previous version. So we had to look into a lot of websites and Jetty's Jira and a lot of blogs which said what all changes were made from the previous version. The next challenge we faced was the dependency issues. So after we changed the Jetty's version, we found out that there were many dependencies which were required for Jetty 9 to run. For instance, Jetty 9 used Java Servlet API 3.1.0, whereas Ambari server used Servlet API 3.0.1. So the first thing we did was to solve all these dependency issues. So as you can see, there were a lot of dependencies which were changed in the Ambari server's pom.xml with respect to the Jetty 9 upgrade. Now the next thing was to look into the classes which were affected by this upgrade. So as you can see, these are some of the changes which we made for upgrading to Jetty 9. A major change was in the Ambari server class. So this is the main class which initiates the functioning of Ambari server. Now, as I said earlier, Jetty 9 was a huge upgrade from Jetty 8 in the sense that many classes were changed, many APIs which were available in Jetty 8 were now abstracted in Jetty 9. For example, in Jetty 8 there were different set of connectors which you use to connect to the server. For instance, SSL select channel connector, then there is select channel connector, but in Jetty 9 they have abstracted all these connectors to a single generic server connector. Also, in the previous Jetty 8 version, you just need to pass the context factory instance into the connector which you used to connect to the server, while in Jetty 9 you need to instantiate HTTP configuration API and then pass this configuration as well as the context factory into the server connector. Also, there were some changes made to the server class. So in Jetty 8 you need to pass the thread pool size dynamically using set thread pool API, whereas in Jetty 9 you need to pass this thread pool size into the constructor of the server instance. Also, there are many small changes in different set of classes in Ambari server module. So these are some of the changes. Now next, another issue which we faced after configuring the Ambari server classes was that after running the Ambari server we are not able to load the JavaScripts and the style sheets from the Ambari web. So we found out that the JSP engine that was used for Jetty 9 was different. So the web content was stored in the compressed form. So what we did was we changed the JSP in Ambari web pom.xml and used a JSP which didn't compress the web content. So these were the changes which we made for upgrading Jetty server from 8 to 9. So now, as a part of project deliverable, we have submitted a Jira for upgrading Jetty server from 8 to 9. Moreover, we have submitted a patch on the review board and submitted a review request for the same. So as of now, the state is like we are successfully able to start the Ambari server and do the installation. Of all the unit tests for Ambari server, 5 out of 6 have passed and the one test have failed. The reason is that there is a cyclic dependency between the current thread pool size implementation and the new the APIs which are not present in Jetty 9. So we are right now in talks with another Apache Ambari member, Jonathan Hurley, and we are working on solving this issue as of now.